Velux has been making skylights and roof windows in Europe for over 65 years. We've been in the US over 45 years with our skylight business. We are known for our skylights. That is our core business. About 10, 12 years ago in Europe, they started selling solar hot water systems. We did not bring them into the US until 2008. This past year, we brought them here. So what we've done is, typically, back in the 80s, we were used to the solar hot water systems that were on the roof, where you saw the pipes and the collectors all pitched, very, sometimes not so aesthetically pleasing. With ours, what we've done is taken those collectors, and in Europe over the past 10 years, they've been designing what we think is the perfect system. They actually integrate our collectors into the roof like our skylights. So as you can see here on the roof, the collector that's been installed, it sits flat on the roof deck. It's flashed in, it becomes part of the roof. If there's ever, if you want to replace your shingles or put a new roof on, the solar system stays in place. You just pull shingles off around it and re-roof around it. So, again, what we've done is taking that solar collector, put it in the roof with our Velux flashings and the knowledge that we've had for 65 years. The leak-proof design that Velux has come to be known for. Basically, what this is going to do, it's going to provide at least 80% of the annual hot water needs for the homeowner. They will, during the summer months, they'll get 100% of their hot water from the sun. During the winter months, that can be down in the 60 to 70% range, depending on how many days consecutive sunlight you have and stuff like that. When you get cloudy, overcast days, it'll only provide about 60% of the needs. Because you've got the PV system, the photovoltaic system on the roof, it's going to generate and offset the hot water, or the electric hot water that you're generating from the solar system. During the summer months, again, both systems will be generating excess electricity and hot water. With the electric company, they should get money back from the electric company during the summer months that will offset any electricity that goes into heating water during the winter months. So on an annual basis, they'll actually net zero. They won't pay anything for their hot water, their electricity, and with the space heating system as well. Everything, all those major utilities are going to end up being free to them.
So we're now putting the finishing touches on our installation in the garage of the pump station, our expansion tank, and our hot water storage tank. So with the glycol and the distilled water, we're keeping the temperatures in the system from getting too hot. As the collectors reach their max temperatures on the roof, we'll start to push some of that heat to our storage tank. Because the temperatures in the collectors up on the roof can almost get to 400 degrees. So it's extremely hot when you consider the water coming out of our mixing valve is only going to be 120 degrees going into the house. We'll program the controller so that the temperatures in the collector, once they get very hot, they'll start to bleed that heat through the flex lines back to our pump station. As the temperature in the storage tank begins to rise, there's an additional thermostat in the tank sending information to our controller, which lets us know when the set point has been reached in our temperature. Basically what that's doing is saying when the tank is hot enough, it's not going to take any more heat from our collectors. All of this is designed to keep that electric element from firing, because the whole purpose is to take as much energy from the sun and turn that into hot water for the customer. The two flex lines that are coming through the attic are coming from the collectors. The left side line is our return line coming from the hottest collector on the roof. So this is the hot side coming into our pump station. This is the cold side of the return side. So as the storage tank and the pump station begin to work together and bring the cold glycol fluid back through, they'll push the fluid back up to the collectors to heat it. Once it reaches a certain temperature that we pre-programmed in our controller, then the pump cuts on and brings the hot fluid back through the pump station, back through these flex hoses, and heats inside this storage tank. There's a copper coil, if you will, inside this tank, and it acts as a heat exchanger. So the hot fluid inside here is actually radiating heat through thermal transfer. Basically, the hot fluid comes through the hoses and stops right inside the coil. And it could be 200 degrees or more in temperature. That heat exchange takes place inside the storage tank, raising the set point temperature in this tank to 130, 140, 50, 60, whatever temperature we set this tank to be.
Once it's installed and you actually see all the 3 collectors up there, I think it'll be much better. You realize that all you see is a skylight look. You won't see any pipes exposed on the roof. Everything is underneath. It's so it really is a very clean look, very low profile. The collector surface is only about 3 inches, 3.5 inches above the roof deck. So it really integrates well into the roof designs. And we're doing it on, this roof is going to be a shingle roof, but we can do this with tile roofs as well. Our solar systems can be installed on metal roofs, on tile roofs, on shingle roofs. We have different configurations for each type of roof.